Hello, and welcome to Math Matters. I'm Miss Ogden, and today we're going to make connections amongst representations of proportional relationships. For this lesson, you will need paper and a pencil or something else to write with. We will pause while you take a moment to gather those materials. All right, let's get started with the warm-up. Take a look at Graph A and Graph B on your screen. What's the same? What's different? Jot down any similarities or differences you might notice. You might notice that one way the graphs A and B are different is that their lines cross through different points on the coordinate grid, or that graph B has a steeper slope than graph A. You might notice that one way graphs A and B are the same is that they both have the same scale and count by ones on both the x and y axes, or that both graphs show a line that passes through the point of origin, which is the 0 point on both the x and y axes. This means that both graphs show a proportional relationships. We'll dig deeper into that a bit later. Now let's take a look at a real-life scenario. Read the problem on the screen as I read it aloud. An animal shelter has a ratio of 4 cats to 3 dogs. How many dogs will be at the shelter if there are 60 cats? We're going to explore some of the different ways that 6th graders solved this problem. Remember, math is all about patterns and relationships. See if you notice any patterns and relationships as we move forward. Take a look at one 6th grader's strategy. Levi drew a picture, which is one strategy that mathematicians might use to solve this problem. What do you notice about the relationship of cats to dogs? What do you think would come next if he were to continue drawing this picture? Levi knew that for every 4 cats, he would need to draw 3 dogs. So he began to draw groups of cats and dogs. After a while, he thought, gosh, it's going to take me so long to keep drawing these groups until I get to 60 cats. He wondered if there was a way that he could solve the problem more efficiently. So he talked to his friend Kaybree. Let's take a look at her strategy. Kaybree was excited to share her strategy with Levi and to see what he came up with. Kaybree used a table, which is another way that mathematicians might solve this problem. What do you notice about the relationship of cats to dogs in Kaybree's table? Kaybree knew that if she set the problem up with a table, it would help her notice patterns. She noticed that she could skip count by 4 on the left to represent the number of cats at the shelter, and she could skip count by 3 on the right to represent the number of dogs. She continued to extend this pattern on both sides until she got to 20 cats on the left, and then she realized that she could multiply 20 by 3 to get to 60 cats. She knew that she could then multiply 15 times 3 to get the missing number of dogs on the right. Kaybree knew that the ratio of the number of cats to the number of dogs would always be 4 to 3. She also remembered that multiplicative relationships are always proportional, so the number of cats would always be proportional to the number of dogs. If she multiplies the number of cats by 3, she would need to multiply the number of dogs by 3 to keep that relationship proportional. Levi and Kaybree were so excited to compare their strategies. They know that mathematicians are always thinking about how different strategies are alike and how they're different. Take some time to think about the ways that Levi and Kaybree's strategies might be similar or different, and write down anything you might notice. You might have noticed that one way Levi and Kaybree's strategies are similar is that they both represented the number of dogs and the number of cats in groups. Levi represented the dogs and cats with pictures. He drew 5 groups of 4 cats and 5 groups of 3 dogs. His picture shows 20 cats and 15 dogs. Kaybree represented the number of dogs and cats in a table. Where do you see her 5 groups of 4 cats and 5 groups of 3 dogs? We can see Kaybree's groups of cats and dogs in the 5th row of her table. Here we can see that both mathematicians used a multiplicative relationship to represent 20 cats and 15 dogs. You might have noticed that one way that their strategies are different is that Levi drew a picture and Kaybree used a table. Even though both mathematicians used that multiplicative relationship, Kaybree took it one step further. Once she was able to get to a friendly number of cats, 20, she knew that she could multiply by 3 to get to 60 cats, and that she could use that same multiplicative relationship to find the missing number of dogs. She multiplied 15 times 3 to get 45 dogs. After Levi compared his strategy with Kaybree's, he understood how he could have used multiplication to finish solving his problem. He realized that all he needed to do was multiply both the number of cats and dogs by 3 to get that final ratio of 60 cats to 45 dogs. Levi and Kaybree were curious if any of their classmates tried a different strategy, so they went to check in with Marvin. Marvin decided that he was going to use equations to solve this problem. which is one more strategy that mathematicians might choose. He started off by drawing a table to show the ratio of 4 cats to 3 dogs. And then he used what he knows about multiplication to solve the rest. He thought to himself, 4 times what equals 60? And figured out that he could multiply 4 times 15 to get that 60. He knew he could use that same multiplicative relationship to find the number of dogs. He knows that proportional relationships are always multiplicative. And he thought, I can use that same relationship. I can multiply 3 times 15 to get 45 dogs. All three mathematicians were eager to compare Kaybree and Marvin's strategies. They noticed a few similarities and differences. I wonder if you might be noticing some of the ways that Kaybree and Marvin's strategies are alike and different. Take some time to jot down what you might be noticing. One way that their strategies are similar is that they both used a table in some way, and both multiplied the number of cats and dogs to get the same ratio in the end, 60 cats to 45 dogs. You might notice that one way that they're different is that Kaybree extended the pattern in her table, and Marvin used an equation and what he knew about multiplication to find the missing number of dogs. They also multiplied by different numbers to get their final ratio of 60 cats to 45 dogs. Kaybree used her table to get to 20 cats and 15 dogs. Then she multiplied each by 3 to get her answer. Marvin multiplied both the number of cats and dogs by 15 to get his. After comparing their strategies, Levi, Kaybree, and Marvin understood how they were similar and different. They felt proud that even though their strategies were different, they either got the same result or had a strategy that would have led them there in the end. Think back to some of the learning that we did last week. We talked a little bit about how mathematicians might create ordered pairs so they can plot points on a graph. You can see the table that Kaybree created on your screen. We can use her table to create ordered pairs. We can represent the number of cats as the x coordinate and the number of dogs as the y coordinate. Once we've got our ordered pairs, we're ready to plot points on a graph. Plotting the ordered pairs is another way that mathematicians can tell if a relationship is proportional. When we connect the points that we plotted from our ordered pairs, we can see that the line would pass through the point of origin. When this happens, it's another way that mathematicians can prove that a relationship is proportional. Remember, mathematicians are like detectives. We're always looking for patterns and relationships, and we're always thinking about how strategies are connected. We dug into a real-life scenario today that involved proportional relationships, and we zoomed in on 3 student strategies to see how they were alike and different. Levi drew a picture. Kaybree used a table, and Marvin used an equation. All 3 mathematicians used the proportional relationship of cats to dogs to solve the problem. Then at the end, we thought about how we could use ordered pairs to create a graph that would also represent that proportional relationship of cats to dogs. Even though each mathematician's strategy was different, each got the same result in the end. If you used a different strategy, that's okay too. I hope you'll continue to think about how strategies are connected as you solve problems today and every day. If you learned a new strategy today, I challenge you to try it out the next time you solve a problem. In today's episode of Math Matters, we explored a real-world scenario to learn about proportional relationships, and we explored different strategies that mathematicians might use to solve the problem. Take a moment to jot down something you learned and something you might be wondering. I'm Miss Ogden. I hope you have a great day and keep on counting.